Hello everyone, I am Abhishek and today we are going to solve permutation problem. So in permutation problem we are given some number of arrays like array of numbers like 1 2 3, and we have to return all the permutation of this array. Like for 1 2 3 it will be 1 3 2 or 2 3 1, like that all the possible combinations we need to return. So here our constraints are given very less, like length is 6, and like number of I we can have from minus 10 to 10, like these number we can have from minus 10 to 10. And the length, like here the 3 length of the number is 3, nums is 3, so we can have at most 6. So we can have any solution which has time complexity of exponential time complexity, or we can have factorial time complexity. uh, we can have the worst time complexity here, which we can do as the constraints are less. So let me find out how we can do approach this solution first. If 1 2 3 is there, then we can put our 1 2 3 as fixed, or 1 is fixed, 1 2 3. Then we can have 1 edge fixed, and we can change the 3 and 2. Like basically we're swapping it here. And then as our 1 2 3 swapping are done, this is done, then we can have 2 1 and 3, 2 1 3. So basically we have swapped 2 and 1. Then after that we can swap from here itself 1 and 3, like 2 3 1, 2 3 1. So basically we are doing swapping here. So we need to do swap here on all the indexes. So on every 2 index we need to have our swapping. And if one index is swapped, we need to go to the next index and we need to swap that from there. So here let's straight away go to the solution first, how we can do it, and then I will try to make you understand like how the solution will be working. So first let us make result array, then result array is only required. And okay, let's first make a helper function where we will pass our nums. Nums is the array which is given to us, in which we have to execute our permutation. And then okay, let's start with 0 index and let's pass the result, and at the end we will just return the result. We will have our void function here, helper nums. We need to pass the nums here. I am passing the nums here as a reference, and here we have the index, and at the end we will be having the result here. Then we can write our base condition here. Base condition is whenever we will reach the nums size, index equal to nums dot size. If I'm not wrong, this should be the base condition here, because we need to traverse through all the indexes, and whenever we reach out of bounds, like index becomes greater than the last index, then here just we need to push back. I will write the push back later, what we need to push back, but this should be the typically our base condition. And the next would be I need to swap it here. I need to swap my index, or basically the nums of index and with the next digit, then with the next digit. So first thing, okay, we need to add one for loop where we will traverse our index from not 0, basically from index we will traverse, and I plus plus so here we will be doing the swapping because we need to keep our first, if it is in the first index we need to swap all the digits. Like if 1 2 3 is there, we need to swap first one, this one, and I am doing it from I equal to index because I also want this 1 also here. So if I start from the index plus 2, I will start from 2 because the swapping will be done, and for element 1 in the first index will not come. That's why I have to like start it from the index here, index 1, then I need to swap with index 2, then I need to swap with index 3. And whenever I will swap, I need to go to the next index and swap it from there. So I will have this one fixed, this part is fixed, and I will swap it from here. Then like that I will have this part is fixed, and rest all the other part whichever will be left out I need to swap it. So I have to swap it from I in index to this here, and I just need to call idx plus 1 because I am making here the first index fixed, and then I am calling the idx plus 1. Then I need to if 1 2 3 is there, so nums only I am passing, so in the nums I am swapping it without using any extra space. And then we can swap backtrack. We will do basically the backtrack from here. We can swap basically whatever we have swapped here, because I want the original number back whenever I am coming out of my function. So whenever this function work is done, I need to come back to my original shape so that I can swap with the next digit. Because whenever 2 1 will be there, okay, if 1 2 3 is there and I have swapped 2 1 2 then 1 then 3, then I will have if I am not backtracking it with swap, then whenever I will go to the next index I will be swapping the 2 and the 3, because 1 and 2 and 1 we have swapped, 1 will be present in the middle and 2 will be present here and 3 will be present here. So basically after that we will be swapping 3 and 2, 3 and 1, or yeah, 3 and 2. So 3 and 2, so 3 will be here, 2 will be here, 1 and 2 will be here. So it will be like 3 1 2. So I want my third position to be fixed, so which I am getting it obviously, but if I am not backtracking it, right, if I don't backtrack it from here, so 3 1 2, and if after doing backtrack if I have done here, then it will be 3 2 1. So basically the first index only I am swiping out till to here, So if I'm changing the order, I only want at a time, I only want one element to be uh, changed. So if I don't swap it like this, I feel I need to swap it, but yeah, the question is why? Why do we need to swap it here again? Because this swapping makes sense because we need to make it. We need to make one element fixed with some other element, because for first time we have did with one, for second time we want two index to come to one, and third time we want third index to come to one. Correct. So if we're not doing this backtracking swapping, that then there might be any case that whenever we are going from like 3 to 1, okay, if we did these steps and we are not backtracking it, then what will happen is if there is any fourth stop here, fourth stop, then here we'll be swapping like 4, 1, 2 and 3. But here I actually want it as 4, 2, 3 and 1, because I don't want to change the order, because if I change the order, my permutation will give me the wrong answer. Like if you are getting the sense or not, I'm not sure of. So I'm trying to make you all understand like why do we need this swap, why do we need to backtrack it. So I'm trying to find out some example where I can explain it in a better way. So basically I only want to change this thing with some other thing, but if I am not backtracking it, if I'm not swiping it back to the original shape before I swipe it further, then I might end up in a wrong answer, because there might be chances that we will get the same answer again. 3 to 1. How can I explain it to you? 1, 2, 3 is there. Okay, 1, 2, 3. If I'm not swiping back, I want this 3 to 1. But if I'm not swiping back from there, if I've swapped first, if I have swapped 1 and 2, then I will have here, previously I will be having here 2, 1 and 3. So just I am focused on this function, the function which has index 0. So if I am not swiping it back, I will not have an order. There might be chances that I will get this 3 multiple times, because I only want the 3 to come only once, and then the rest of the thing should be coming. But I might end up making multiple swiping with the same number, because there might be chances that when I am swiping, for suppose any example, I'm not getting any example actually which I can explain it to you. If it is 3, 1, 2, then 4, 1, 2, 3. It's 3, 2, 1, then 3, 1, 2. Like let's say, for suppose we got something, we have something as 4 also here. Okay, let's say suppose we have something as 4, and we previous to that we have calculated all our permutation with fixed, with zero index to be fixed with two value. But for suppose we now we are trying to swap the last element with the first element. Okay, and it might happen that while doing the permutation combination we end up with 3 1 4 and 2, because eventually we are swapping, we are not calculating anything, we are not checking anything, we are just doing the swap. And whenever we reach the end of the index we are just we'll do the pushback our, okay, we need to push back the nums only here. We need to push back our nums, which is the number which we have swapped. So there might happen that this kind of situation will occur, and at when we reach this function with index 0 swapping, uh, we will be end of swapping like 2 1 4 and 3. So this 2 is coming again one more time, because previously we have calculated with 2 index fixed at the first, and we have got all our permutation combination with that, and after that we are again calculating it, which like we might calculate the duplicates of it. So that's why we need to backtrack it from here. I think that's only after swapping we can just check it out. Yeah, let's see if our answer is correct or not. N is not given. Okay, nums dot size. Yeah, so this comes to our end of our solution, and we don't have actually here any tabulation approach, because we need to do here recursion. There is no DP, no tabulation, nothing here, because we need to find all the possible solutions. Every time we are getting some new solutions here, so that's why we need to have this time complexity. And let's calculate the time complexity also here. So time complexity, I think here it will be little trickier, because on every cases we are running our for loop from n, then n minus 1 times, then n minus 2 times, then n minus 3 times, till we reach 1, till we reach 1 or 0, till we reach the 0. And then, or till we reach not 0, like till we let's say till we reach 1, because we are considering n here, and there are like nums of size equal n nums of size, and let's take first element as 1. So here this gives us like n factorial here. N factorial, then inside the n factorial we are doing the swapping thing, and swapping can be 2c, like 2 into constant times complexity, and helper will be called for it for every n factorial thing. Helper is called and the helper will do our so at each helper will go from n factorial, okay, because on each function call it will be n minus 1, n minus 2, like that it will be decreasing till n, and it will be n factorial, and the swapping thing will be done at 2c into 2 times we are doing or 3c into 2, because 3 swiping needed 3 operations, and we can do optimally. Swiping can be done optimally with 2 operation also, with that plus and minus thing, if you know that. But let's suppose this swiping takes 3c, and helper, each helper function it is pretty much sure that here the time bomb, this will be like n factorial for every function call, and for helper here it is 2c, and let's say like if index 1, for index 1 it is called index 1 2 3 like that. If for one thing it is going to call again with some n factorial thing, and then it is called again for the n factorial thing. So for every function call there is this n factorial, and how many function calls can be made. So there are total n factorial function call to be made. So basically the time complexity will be n factorial only here, because maximum time complexity, maximum we can get is factorial. So here the time complexity, to be sure, it is n factorial. O of n factorial. Okay, that's it. If n factorial only, correct. I need to go into a little depth here. I am not sure where. I am pretty much sure this is n factorial only, but I am not sure what will be the exact time complexity here. Exactly, to be precise, it is n factorial. Exactly, I need to go little depth here, and if I got some material how we can find this time complexity, I will get back with this video. And for now, like, thanks for watching this video. Hope you understood the solution, and I will get back with the time complexity thing. And thanks for watching.